Hello guys and good day. This is the part 3 of our lecture in module 3 in our subject organic chemistry. Now, ang discussion lang na magaganap nito guys is yung explanation behind our experiment or the methods of separation which involves three different separations naman yun. And those are distillation, crystallization, and paper chromatography. And my apologies, guys, since I didn't prepare a lecture PowerPoint for our discussion. But so I will use the theory not used in the OLabs. So I acknowledge this one. So kinikredits ko siya. Laking tulong siya ngayon. Dahil may mga virtual labs siya, guys, na pwede ninyong gamitin. Hindi lang sa chemistry. Meron din sa may math, physics, and biology. So ayun, in-advertise ko lang para ma-acknowledge yung website. Now, ang uunahin natin, ang mag-discussion natin is yung, distillation. Distillation. And distillation. Next is the crystallization. And last is yung ating paper chromatography. Okay, punta tayo sa first part ng ating discussion, which is the simple distillation. Okay, the simple distillation, guys, ang usually sineseparate niya is the mixture of two miscible liquids without decomposition. Guys, ang gagawin nila doon is converting the liquids. Let's say, for example, sa ating experiment, we have the ethanol and water. Ang gagawin lang nun is you have to heat the substance first at the simple distillation with lower temperature, yung lower temperature muna, which is the ethanol, which has a 676.37 degrees Celsius. And for simple distillation, guys, it only involves two miscible liquids lang. So, dalawang component lang dapat when we are using or separating liquids, simple distillation lang. So, ang gagawin lang dito, guys, is just heat. So, di ba, boiling or vaporization, converting the liquid into what? Gaseous state. So, mangyari doon, magpo-flow yung gas dito. Yung condenser, ang purpose ng condenser natin, guys, is may dumadaloy kasing tubig dito or cold water na yung gas natin, di ba? At kapag bumabay temperature, the gas will be converted into liquid. So, magkakaroon ng condensation using the condenser at sasaluhin ng ating round bottom flask, makuha na natin yung component with lower temperature. So, ang natin dito is, ethanol ba? Sorry, guys. It is acetone and water pala yung ginamit natin dito. Okay, so kapag magsiseparate kayo, ang kukunin nyo dito sa may round bottom flask is yung liquid at the miscible liquids yung may lower temperature. Hindi ninyo pwedeng kunin yung water kasi parehas silang mababaporize, parehas silang ma-condense, and mixture din yung ma-ano dito. So, lower temperature yung gagamitin natin. So, yun yung principle nun ng ating distillation setup. Yun lang naman ang principles niya. Ayan, so basahin na lang ito. This will be your reading assignment for this explanation. Now, for the second naman is the fractional distillation. Mas naman ito. Mas high-end naman siya, guys. Pero there's a constraint at this. Constraint hindi. At ito, dapat meron tayong fractional distillation used to separate two or more. So, more than two. Miscible liquids, difference in boiling points is less than 25 Kelvin. So, dapat less than 25 Kelvin. So, ganun ang magiging difference ng kanilang boiling points. Ngayon, ang pagkakaiba na lang naman dito, guys, is meron tayong fractionating column. Ano ba ang purpose ng fractionating column natin? Nagpo-provide siya ng surface for the vapors to cool and condense repeatedly. So, magkakaroon ng cooling and condense repeatedly. And when the vapor mixture across the fractionating column, because the repeated condensation and evaporation, the vapors of the liquid with lower boiling point will first pass out. Kasi nga, di ba, so sabay yung magkakaan natin, sabay silang makakaan. Ang mangyayari dito is yung may lower boiling point daw, liquid with the lower boiling point will pass out to the fractionating columns and condense and are collected in the receiver flask. The other liquid with a slightly higher boiling point can be collected in similar fashion in another flask. So, ano ba ang mauuna dito? Okay, ang unahin niya dito, guys, mauunang makaan dito is the liquid with lower boiling point. Lower boiling point lagi, di ba? As simple ay ang 1, kapares lang din siya dun sa may ating simple distillation. But since the temperature are more closely, kasi nga less than 25 Kelvin, ang fraction in column nito, yung mas malapit doon is i-condense pa niya yun. And then with the one higher boiling point, mauuna siya doon. And then collect, and then so and so forth. Now, the constraint here, guys, dito sa ating sa ating samples dito, kung paano ay maging familiar, is dapat alam ninyo yung component ng ating samples, search for the boiling points, and now you can separate the material. So therefore, ito, to summarize up, the distillation is used to separate miscible liquids. Okay, ito yung simulation natin. Nandito naman siya. Okay, ayan. So ganun yung mangyayari. It involves heating lang. Bantay-bantay lang yan. Ang mahirap lang dito is yung pag-set up. Okay. So we're done with the distillation. Now, next naman natin is yung ating, magkano ba yung mic ko? Dali nga. Okay, next naman tayo guys is sa ating crystallization. Okay, dito naman sa ating crystallization, it involves a solid. Sa distillation natin, liquid. Dito naman is solid. So okay, ang experiment dito na ating kinandak, ang kinandak ko sa simulation is yung copper sulfate. So ano bang mangyayari? Bakit natin kailangan ng crystallization? Sa may copper sulfate kasi, kapag kinuha nyo siya sa may reagent bottle, may kita nyo doon sa label ng reagent bottle, which wala akong mapapakitang demo kasi wala ako sa may laboratory, is makikita ninyo yung classifications niya. May makikita yung mga impurities doon such as aluminum and other trace metal doon sa may reagent bottle natin, which implies that the copper sulfate is not 100% pure. So, paano nyo siya isi-separate or to improve its impurity? Nagamit kayo ng crystallization, guys. Crystallization. Okay, paano ba mangyayari doon? The process, okay, ano lang naman natin to is, ang mangyayari doon is, first and foremost, syempre, di ba, solid to, you have to use a proper solvent. Proper solvent lang ang kailangan ninyo, guys, para ma-on natin kung paano ma-crystallize ito. Okay, ito yung principles. Okay, just read it out. Pero isa-summarize ko naman siya. Ngayon, ang on dito is, ang principle naman ng crystallization natin, guys, is to eliminate the impure or the trace impurities from our copper sulfate or any other metal. So, paano ba mangyayari doon? Unang-una, di ba, sa ating simulator natin is ito. Okay, next. Wait lang Okay, ang mangyayari dito sa ating simulator, guys, sa ating simulator, okay, hindi ko makuan. Hindi ko siya makuan. Wait lang Okay, sa ating purification, ang mangyayari dito is, syempre, we have this copper sulfate. I-dissolve nyo siya, impure copper sulfate, i-dissolve nyo siya sa may water natin. So, ayan. And then, lalagyan nyo ng H2SO4 para mag-interact yung mga species natin or yung mga natin, yung mga other interfering ions since na-dissolve na siya sa ating copper sulfate na ganyan. So, ganun. Ayan. So, next natin is to, syempre, yung mga soluble and insoluble materials na nag-precipitate dun sa may copper sulfate natin will be separated from the filter paper. So, i-filter na natin siya and sasaluhin siya ng ating evaporating dish. So, ganyan yung mangyayari. Pero hindi natin siya pwede silipin. Ngayon, ang mangyayari ngayon dito, guys, is since na siya, ang gagawin nyo is to heat the copper sulfate hanggang ma-vaporize yung ating yung ating solids. And ayan, you have some dissolved substance. And i-cool nyo siya, guys, para magkaroon ng crystallization process. So, bakit ba natin kailangan ng crystallization process? Kasi nga, ang ating copper sulfate, okay, copper sulfate, ita-type ko lang, sorry. Copper sulfate, guys, is, dapat pala, ni-ready ko na. Crystals. Okay, sa ating copper sulfate crystals kasi natin, na ganyan, crystal lattice, I should say, sa crystal lattice kasi natin at molecular level, ganito yung itsura niya. So, ang mangyayari dito is, merong natatrap na impurities. Natatrap yung impurities doon sa may crystal lattice ng ating copper. Di ba? Nandito siya. O ayan, we have this copper sulfate crystal here. So ang mangyayari doon at dissolution, ni-remove natin yung interfering ions. Pinunta natin doon sa may tubig and doon sa may diluted sulfuric acid natin is further precipitation ang mangyayari doon. So mawawala yung ibang impurities. Ngayon, ito, hinit na natin siya and then nagkaroon ng crystallization, i-remove na natin, and then the ethyl alcohol and cold water is used. Kaya cold water is to further remove the impurities present in our copper sulfate solution. So bakit may ethyl alcohol? Para ma-remove din yung other non-polar or slightly non-polar dun sa ating copper sulfate. And then yung cold water para hindi ma-dissolve totally yung ating copper unless magkakaroon naman tayo ng dissolution nila. So, ganun yung mga. And then at drying, ayan, talagyan na natin yung copper sulfate crystal natin dito sa ating test tube. And voila, meron ka ng copper sulfate and hindi ko siya mailagay. So ganun, tatakpan nyo lang ng cork since copper sulfate is hygroscopic para hindi siya magkuha ng water. So ayan, meron na tayong copper sulfate crystal. So that's the theory in our crystallization process. So ito yung mga process niya. Ayan, ayan, and ayan. So ito. Ayan, no? So ang pinaka-crucial dito, guys, is the selection of solvent. Proper solvent must be selected para ma-employ natin yung solubilities ng ating substance na i-crystallize. So ayun. Okay, now so we're done with distillation and crystallization, copper sulfate. Next naman is the paper chromatography. Ano ba yung ang chromatography natin? Okay, ang chromatography, guys, is used to separate the organic components in our sample. Okay, sabi dito, are all organics pure? The answer is no. Most organic compounds obtained from natural sources and synthesized in laboratories are not pure. So since hindi siya pure, kailangan mo ng various methods of purification of organic compounds based doon sa may nature ng compound. And among those separation techniques, guys, is the, chromatography. Chromatography is one of the most important separation techniques used to separate their mixture into their individual components and purification of the compounds. So what is chromatography? The word originated from the two Greek words, chroma means color and graphene means write. So color writing, and it was first employed by Russian scientist named Mikhail Chebet. Okay, babasahin nun lang ito, guys. Just post the video. Pero pupunta na tayo doon. Let's cut to the chase na kasi magiging reading ko to. Sir, binabasa nyo lang naman. Dapat sinabi nila sa amin yung site. Okay, isa-summarize ko na siya, guys. There are many types actually of chromatography. We have high-performance liquid chromatography. We have gas chromatography. We have column chromatography. We have thin layer chromatography and paper chromatography. Okay, ang scope lang ng ating discussion, guys, is the paper chromatography. Okay, i-discuss ko lang shortly itong column chromatography na to. Ang chromatography natin, guys, dito, makikita nyo naman siya dito, mabasa siya dito, is composed of mobile phase and stationary phase. Okay, ano ba yung mobile phase natin? Yung mobile phase natin, dito, is yung naka-standby. Okay, para mas makarelate kayo, guys, sa ating pinag-uusapan, ang mobile phase dito sa atin is yung paper. Ito, yung as defined here, siya yung, nasaan na yun? Ay, stationary phase. Sorry guys, stationary phase. Siya yung naka-standby. As applied, ito, pwede siyang solid or liquid. And yung isa naman, the other component, is the mobile phase. The mobile phase is the solvent that you use to separate the components. Now dito, sa ating spinach here, okay, kukuha tayo. So meron siya mga component dito. Kukuha tayo dito. Ayan. So, ibig sabihin, ang stationary phase natin dito is the paper. And then yung ating natin dito, yung ating mobile phase, stationary phase paper, mobile phase is the isopropyl alcohol plus water. So, through capillary action, guys, aakyat yung water natin na isopropyl dun sa may solvent front, pero iwan muna natin yan. So, ganun mangyayari. In terms of column chromatography dito, this one here is separated based on their molecular size. So, paano ba yun? We have these mixtures of samples. Separate nyo, may mauuna, may mauhuli, may iwan. Ganun naman talaga, di ba? Tapos sasaluhin mo kasi mapo-fall. Ganun. So, ayan. And then, kapag turn na nung isa, sasalihin mo lang ulit and then nasa-separate mo na yung compounds. Ganun. Pero guys, tandaan nyo, mahirap gawin yan sa totoong buhay. Kasi gagawa pa ng silica gel, which is your stationary phase. Kailangan kon pa siya, perfectly fine. At wala kasing demo, pero dapat na. Okay, and then, here, same principles lang din. Sa paper, okay. Yan. So, dito is sa ating paper chromatography. Here, okay. Now, after 30 minutes dito, balik na tayo sa ating experiment. Kung makikita ninyo guys, is na-separate yung ating mga components dito. Na-separate yung components natin after 30 minutes daw, pero hindi na siya na-one. Ayan, na-separate na siya. Kasi nga, nakadepende yung components natin, di ba, dito. Sa components natin dito sa ating sample is we have 4. The chlorophyll B, chlorophyll A, xanthophyll, and the beta-carotene. Nakadepende kasi, di ba, sa ating intermolecular forces na pinag-aralan natin kanina, di ba, is nakadepende interaction nila with the paper or the stationary phase, yung separation, with the relative to the solvent or dito the mobile phase. Doon magbe-base yung separation nila kung gaano kalakas yung interaction nila. So in terms of this guys, mapapansin ninyo, nagkaroon na ng separation. And then we have to calculate for their RF values here. What is the RF values? Ito ay values ng mga specific compounds natin. They have their own RF values. Para ma-prove natin, i-search natin. Okay. RF values. Okay, may search na pala. Of chlorophyll A. So, ayan ang mangyayari. It is a pigment, beta-carotene. So, every compound here dito has its own RF value that distinguish them from the other compounds or other components of our organic compounds. And ika-calculate nyo lang siya dito based from the kung natin, ito, okay, let's say this one here. Gagamit tayo ng ruler. Okay, okay. Now, nasan yung ruler natin? Wala tayong pan dito. Okay, okay, let's show the scale. Ngayon ang mangyayari dito, the divisor will be 5-inch. Kasi hanggang dun yung solvent front natin eh. Now dito, kunin natin itong dark green natin. Ano ba yung dark green natin? The chlorophyll B. Kukunin mo lang siya dito. Okay, ibababa natin siya. Okay, wait lang. Bababa natin. Okay, okay. The chlorophyll, the dark green daw, ilang inch daw siya is 1.1 inch all over 5 inch. So therefore, ilalagay mo siya dito na 1.1. Ikuan mo lang yan. Ayan. Sa may light green naman natin, guys, ang pan nun is, ilan daw siya? That is 2.3. 2.3. And then here sa atin, sa ating orange or the beta-carotene here is 4.7. And then for the yellow is 4.5. So, ayan. And then, in order to calculate for the RF values, ang divisor lang natin, guys, dito is ano lang natin? Ay, divide mo lang siya. Bakit nawala? Chlorophyll B, dark green. RF values is just for chlorophyll B, ilan ba yung solvent front natin? 5. So, therefore, chlorophyll B is 1.1 divided by 5.0. Ang sagot natin is 0.22. So, makuha mo yung RF values niya. Hey, ba't wala? Chlorophyll B, dark green. Wait lang. 1.1 plus 5, so 0.22. Pero bakit ganon? Ba't hindi siya 1? Pero dito, tignan natin dito sa 2.3 divided by 5. That is 0.46. Bakit kumakan? Okay, ipopost ko muna. Saglit, wait lang. Okay guys, na-identify ka na error ko. Hindi ko pa pala nalalagyan ng distance traveled by the solvent. So, ayan, kung makikita ninyo, is ang mangyayari dito, okay, ano ba ang formula ng ating RF value? Distance traveled by the component from the original line over distance traveled by the solvent over the original line. So, our divisor will be the 5.0. Okay, 5.0. And then all over yung ating 1.1 dito, ating chlorophyll B, 1.1, that is 0.22. 0.22 yung in-enter ko kanina, so that will be checked. And then so and so forth for chlorophyll A, 2.3 divided by 5 is equals to 0.46 here. And then for the xanthophyll, 4.5 divided by 5 here, that is 0.9. And then for other beta-carotene, ating beta-carotene, nasa may beta-carotene, 4.7 divided by 5. And that will be 0.94. 0.94. So, tumama ba sa ating literature? Okay, beta-carotene 0.98. Pero syempre, experimental value naman yan. So, ganyan yung ating paper chromatography. Ang pinopoint ko lang dito is every compound or components of the organic compounds has its own RF values. And their separation or the separation rate will be affected by their relative interaction with respect to the stationary phase and mobile phase. Stationary phase is in paper chromatography will be the paper, and the mobile phase in our experiment or virtual experiment are the isopropyl alcohol and water. So that will be the end of our discussion, guys. And see you in our next module. Thank you for listening.